In this lesson, we're going to go over 11.3 graphing an equation. Now, before we start to learn how to graph an equation, we're going to go over some important vocabulary words, and we're going to review how to graph a point on a coordinate grid. So the first word we're going to go over is coordinate grids. And coordinate grids are grids that are used to locate points on a plane. And it has a horizontal number line and a vertical number line. So an example of a coordinate grid is the grid that's pictured below. We're going to now talk about the parts of a coordinate grid. So in a coordinate grid, there's something called a y-axis and an x-axis. The y-axis is the vertical number line. The x-axis is the horizontal number line. So when you're plotting a point, you're going to be given both an x-coordinate and a y-coordinate, and that tells you how far you're going to go horizontally and how far you're going to go vertically. The x-coordinate is the first number in an ordered pair, and the y-coordinate is the second number in an ordered pair. So let's take a look at the 2 points that are already plotted for us on this coordinate grid. So point A says 2, 5 in parentheses. The x-coordinate is the first number in the ordered pair, and so that tells us that we're going to move over 2 spots in the x direction, and then we're going to move up 5 spots in the y direction. And that tells us where we need to plot our point. For point B, we have 4, 3. So the 4 tells us we're going to move over 4 places on the x-axis, and the 3 tells us that we're going to move 3 places up on the y-axis. Now let's practice naming points that are already on the grid. So let's take a look at point M. We're going to first figure out what the x-coordinate is and then figure out what the y-coordinate is. So if we look in the x-axis, point M goes over 1 place. So our x-coordinate is going to be equal to 1. Next, let's look at the y-axis. So in order to get to M, we go up 1, 2, 3, 4 places in the y-axis. So our y-coordinate is going to be equal to 4. Now let's take a look at point N. For point N, we go over 1, 2, 3, 4, 5 places. So our x-coordinate is going to be 5. And we go up 1, 2, 3, 4, 5, 6, 7. So our y-coordinate is going to be equal to 7. Now I'm going to give us a couple of points, and we're going to plot those points on the coordinate grid. First, we're going to plot P, which has an ordered pair of 3, 6. So remember, the 3 tells us that we're going to move 3 places to the right on the x-axis. And the 6 tells us that we're going to move up 6 places. So I moved over 1, 2, 3, and then I'm going to move up 6. 1, 2, 3, 4, 5, 6. So point P is going to go there. Now let's take a look at point Q. Q has ordered pairs of 4, 5. So we're going to move over 4 places to the right, and then we're going to move 5 places up. So we'll plot Q right there. Now that we've reviewed how to plot a point, we're going to start to learn how to graph an equation. Our equations are going to make straight line graphs, which are lines that join the points in a coordinate grid. For our first example, It says Alice buys some granola bars from a supermarket. Each granola bar costs $2. The table shows the total cost of the granola bars. So in our table, we can see that we have two variables, the number of granola bars and the total cost. Now our problem tells us that one granola bar costs $2. So then we can fill out the rest of our table by multiplying the number of granola bars by 2. So if we get 2 granola bars, that will cost $4. If we have 3 granola bars, that will cost $6. If we have 4 granola bars, that will cost $8. And if we have 5 granola bars, that will cost $10. Now each variable represents our x-axis and our y-axis. So on the graph below, we can see that our x-axis is equal to the number of granola bars and our y-axis is equal to the total cost. So we can plot the points from our data table. So we can see that our first point is 1, 2, which we have 1, 2, and then we have 2, 4, 3, 6, 4, 8, and 5, 10. So by plotting those 5 points, we can go ahead and connect those by making a straight line, and that's how we get the term straight line graph. Once we have our graph, if we know an x-coordinate or we know a y-coordinate, we can figure out what the other coordinate is equal to. The equation that the graph represents would be equal to y equals 2x, because every time we add another granola bar, the total cost doubles. In our next example, we're going to take a look at how graphing an equation can help us answer questions about a real-world scenario. In this example, we have a building with some known dimensions. The length is equal to 18 yards, the width is equal to 15 yards, and the height is equal to 24 yards. Mr. Gonzalez wants to build an apartment house with the same dimensions labeled in feet. He uses a graph to help him find the measurements. Mr. Gonzalez knows that 1 yard equals 3 feet, so he uses the equation y equals 3x to draw a straight line graph for values of x from 0 to 24. Each point on the graph shows the measurement in yards and the corresponding measurement in feet. So in our table, our x value is equal to yards and our y value is equal to feet. We can figure out all of our y values by taking our x value and multiplying it by 3. So if x is equal to 3, then y is 3 times 3, or 9. If x is equal to 6, then y is equal to 3 times 6, or 18. So we would follow that same pattern to figure out what our values are equal to in feet if we knew what the value was in yards. We can then take our data table and turn it into ordered pairs that we can plot on a coordinate grid. So in the graph below, all of our points from our data table are plotted already, and they were connected with a straight line that follows the equation y equals 3x. Now if we go back to the beginning of the problem, we were given the length, the width, and the height in yards, and Mr. Gonzalez wanted to figure out what each of those lengths, width, and height were equal to in feet. So we can take a look at our graph and figure out what the values would be in feet. So we can find where 18 yards is, which is right here, and then go and take a look at where 18 yards overlaps with our straight line graph, and that value of the y coordinate would be equal to the number of feet. So in this case, 18 yards would be equal to 54 feet. If we take a look at the width, which was 15 yards, and see where it lines up with our graph, it would be equal to 45 feet. And if we take a look at the height, which was 24 yards, and see where it lines up with the graph, it would be equal to 72 feet. For our last example, we're going to take a look at an equation that's already been graphed and answer some questions. So in this graph, it shows the cost of ribbon, given the length of the ribbon in yards and the total cost of the ribbon in dollars. So our first question asks us to figure out what is the cost of 8 yards of ribbon. So we can take a look at our graph, see where 8 yards is, and then see where that lines up with our equation on the graph. And that would line up here, which would be equal to $16. So 8 yards of ribbon costs $16. Next, we need to figure out what's the cost of 11 yards of ribbon. So again, we're going to find 11 yards on our x-axis and then see where that lines up with our line. So because we counted by twos in our graph, 11 would be halfway between 10 and 12. So it would line up on our line about right there. And then if we see the amount of money that would be, it's halfway between 20 and 24, which would be equal to $22. Now we're going to go in the opposite direction. So now we're given the total cost and we have to figure out how many yards of ribbon someone would be able to buy for that amount of money. So now we have $8, so we're going to find where $8 is and then see where that would line up, and that would be equal to 4 yards. And then our last question is how many yards of ribbons can you buy with $26? So we're going to go and find $26 on our y-axis, which will be halfway between 24 and 28. And then we're going to see where that lines up on our straight line graph. And it would be halfway between 12 and 14 yards, so that would be equal to 13 yards.